Howard Carter's 1922 discovery of Tutankhamun's tomb remains a pillar of popular archaeology. His work represents an era of antiquarianism focused on spectacular finds, the golden mask, the nested coffins. Modern fieldwork prioritizes a different kind of discovery, the exhaustive recording of data points that allow for a reconstruction of the past. We are going to follow the life cycle of a modern archaeological investigation to see how researchers reconstruct history through physical evidence. Before a shovel touches the dirt, we have to address a difficult reality. Excavation is a permanent change to the landscape. Once a researcher pulls an artifact from the earth, they end the conditions of its burial. Because a site can only be dug once, researchers focus on documenting the relationship between every object and its environment before that link is broken forever. Step 1 begins with planning and desktop research. A team establishes a precise research objective and reviews historical texts, maps, and geological records to determine why a specific area merits investigation. Once on site, the team often starts with fieldwalking. Researchers move across the landscape in strict parallel transects, scanning the ground for surface indicators, like pottery shards or stone tools, that suggest a subsurface site. To look beneath the topsoil without moving any earth, archaeologists use remote sensing technologies. Tools like ground-penetrating radar, or GPR, and magnetometers generate a digital map of the subsurface. These instruments detect anomalies based on soil density or minute shifts in the Earth's magnetic field, highlighting the outlines of ancient walls, hearths, or filled-in ditches. Mapping these anomalies first preserves the wider landscape and allows the team to narrow our target from a massive field to a few vital square meters. Step 2 is the physical setup of the excavation grid. The team overlays the target area with a mathematically perfect box grid of string lines, sectioning the terrain into strict, measurable squares. Inside these squares, the modern topsoil, often called the overburden, is removed to expose the archaeologically significant layers beneath. This grid allows researchers to record the provenience of any discovered object. Provenience is the absolute horizontal coordinate and vertical depth of an item, exactly as it rests in the ground. If an excavator digs without recording these coordinates, the project becomes simple dirt removal. An object without recorded provenience is a data point lost to history. The historical evidence an object provides depends on its exact placement, its coordinates relative to every other find in the trench. This trench wall illustrates Step 3, digging stratigraphically. Notice the distinct horizontal bands of stone, soil, and debris. Stratigraphy is the study of these overlapping layers. Newer cultures deposit material on top of older ones. Digging downward moves through a vertical timeline in reverse. As they move through these layers, excavators isolate specific features, like a refuse pit. They carefully define the cut, the boundary edge, and the fill, which is the material deposited inside it. Before any soil is removed, researchers use mandatory recording tools, scaled planar drawings, contact recording sheets, and extensive photography. These records convert a destroyed physical site into a permanent analytical data set. Step 4 moves the investigation from the field to the laboratory. While the physical dig may take weeks, the subsequent lab analysis often takes years to complete. The process begins with carefully cleaning, cataloging, and typologically classifying every single artifact to organize them for scientific study. Scientists then apply specialized dating methods, such as radiocarbon dating for organic remains or dendrochronology to analyze the growth rings in preserved wood. This rigorous verification process separates legitimate research from pseudo-archaeology. Groups claiming sensational finds, like Noah's Ark on Mount Ararat, frequently present unverified samples to the media while bypassing the scrutiny of a lab. The laboratory, through peer review and chemical testing, is where the collected evidence is verified as historical fact. The final step of the archaeological life cycle is publication. Researchers compile their lab data and field records into a formal report. This publication allows the global scientific community to study and debate a site that no longer exists in the physical world. When you encounter a headline a miraculous discovery, evaluate the methodology behind it. Look for stratigraphic records and peer-reviewed lab analysis, rather than just the objects themselves. Fieldwork provides the bridge between fragile physical remains and a permanent, verifiable record of how people actually lived.